Okay, this is more help to help you check this building molecules worksheet. So carbon dioxide. Carbon dioxide has one carbon because there's no number after the carbon, so that tells me there's one carbon. And then there's the subscript of 2 after the oxygen, which tells me that there's 2 oxygens. Okay? So I'm going to connect my carbons and my oxygens. Now, usually when there are different types of atoms, the ones that are the same usually are not right next to each other. So we're going to put the carbon in the middle and then connect the oxygens on the side. So that is what a carbon dioxide molecule looks like. So we've got one carbon in the middle, one carbon in the middle, and oxygen on each side, and they are double bonded. So I can draw carbon, oxygen, oxygen, and they kind of have those double bonds there. Okay, H2O. So H2O, there are 2 hydrogens, because the subscript of 2 after the H. Okay. And then I have only one O. Put one O. So again, we're going to put the one that's different in the middle, and then put the hydrogens on either side. So these ones are single bonds, so I can use the short single bonds. And then when I'm done, all the holes should be fixed. So that is what a water molecule looks like. So I can draw my my oxygen and my hydrogens. Water is what we say looks like a Mickey Mouse, because the way it sticks out like that. This is also what makes water stick together so well, because the 2 hydrogens over here make this molecule polar, so it acts a little bit more like a magnet. Like this end is more positive, and this end is more negative. So we've got oxygen, hydrogens, and the hydrogens are white, so I can leave them white. Okay. The next one, I've got H2O2. All right, well, I've already got these, so I can just take these apart. I just need to add one more oxygen to this one. So I can add an oxygen. And that is what hydrogen peroxide looks like. You could do it like this or like this. It does not matter. It's the same thing either way. I guess I'll do mine like that just to be different. Okay, color my oxygens red. All right, ammonia, NH3. Okay. So I've got H's, I need one more H. So I've got 1 nitrogen, and then the subscript of 3 tells me that there are 3 hydrogens, so I'm gonna put in each hydrogen. Now the hydrogens can only make single bonds because they only have 1 hole. Okay, so I know I'm always gonna use the short bonds with the nitrogen. With the hydrogens. So that's what a ammonia molecule looks like. So I can draw N, H, H, H. Or you could draw it more like a triangle. It doesn't really matter. Okay, ammonia. All right, ethylene gas. So ethylene gas is what ripens fruit. So this is why if you ever have like bananas that have already turned brown, if you put other fruit next to them, it will make them ripen faster, which can be good if you want to ripen them faster. But if you don't want to ripen them faster, then you don't want to put ripe bananas with them. Okay, let me take apart these older ones. All right, so this one I need C2. Okay, so I need 2 carbons. All right, I know I'm going to use double bonds for those. And then I need 4 H's. So I need 4 H's. Okay, so I already showed you a little bit what it looks like. So I've got 2 carbons double bonded to each other. Okay, and then those hydrogens fill in those other holes. Hydrogens on this side. And that is what ethylene gas looks like. So when fruit ripens, it gives off this gas. Sometimes if I have like some avocados that I want to ripen, I'll put them with some ripe bananas. Okay, that's ethylene gas. All right, now we got methane gas. So methane gas is a greenhouse gas. It's not good for the environment. It warms up our atmosphere a lot, but it is the main thing that is in cow farts. Cow farts and cow burps, actually. Okay, so I've got 4 hydrogens with 1 carbon. Okay, so I've got a C, and then a hydrogen, and a hydrogen, hydrogen, and a hydrogen. Okay, 4 hydrogens. This one is a little bit hard to draw because of the 3-dimensional nature of it. So I'm just gonna draw 1 hydrogen up here, 1 hydrogen here. All right, the hydrogens are white, leave them white. All right, hydrocyanide. Okay, so I've got 1 hydrogen, 1 carbon, and 1 nitrogen. Okay, so I can take these off. All right, so I've got 1 carbon, 1 hydrogen, and I need to add 1 more nitrogen. And I'm going to use some double bonds here because otherwise these holes won't get all filled in. Okay, so now I need to ask myself, is a double bond enough? I see I still have a hole here and I still have a hole here, which means I need another bond. Actually, I'm going to rearrange this a little bit, get it to fit better. Oops, ouch. Ouch. Okay, there we go. That is hydrogen cyanide. So I have an N triple bonded to a C, single bonded to a hydrogen. So I can draw nitrogen, carbon, and hydrogen. Okay, color the blue one. Okay. Ooh, this one's interesting. Propane gas. This is what we use in our gas grills or gas fireplaces that are outdoors. We usually use this. Indoor fireplaces usually use natural gas, not propane. But okay, so I'm going to get rid of this nitrogen. I don't need this nitrogen anymore. All right, so I've got a carbon to a carbon to a carbon. And it's showing me here that these are single bonds. So let's go ahead and put in a single bond. Carbon to a carbon. Okay, so I've got 3 carbons in a row, and then I need to add a whole bunch of hydrogens off of all of these. Okay, so this one on the end has 3 hydrogens. This one has 2 hydrogens. And this one. There we go. So I have, let's see, this is going to be hard to draw. I'm going to draw it kind of sideways. And then I've got 3 hydrogens coming off of it. And then only these ones get colored. Okay, that kind of looks like it. And then I've got methanol. Okay, so I can keep this part. This looks the same with 1 carbon and 3 hydrogens. Add an oxygen. And then a hydrogen. Okay, so I've got carbon, 3 hydrogens, oxygen, and a hydrogen. All right. Carbon, 3 hydrogens, an oxygen, and a hydrogen. Color that red. Color that black. And there we go, I'm all done.